Let's look at another demonstration of the pixel processing software. In this presentation, we're going to look at an operation called morphology, and there's at least a couple good uses of this operation. Here's an image of some LED lights, and notice that each digit is made up of more than one LED light with some space in between. If we wanted to try to isolate a particular digit, in this case we would be looking at two or more segments for each of the LED lights that make up the digit, and it's a little more complicated. If there were a way that we could combine these, merge these into a single area, it might be easier to work with or easier to find. And this is where morphology can come in handy. The first thing I'll do is extract the green channel here. So that we end up with a monochrome or grayscale image. And now we can use a morphological operation called dilation, which will expand or grow the bright areas so much so that they'll start to be connected. So we'll go down to the morphology operation, and we will choose the dilate operation. And we can do several iterations of this if we want, and in this case we actually need to. So if we apply 5 iterations, you can see that some of the segments have become connected, but not all of them. So we'll increase the number of iterations, and now they're all connected. Notice here though that the digits have become wider or thicker, and maybe we'd like to reduce that. So what we could do is the opposite of dilation, or erosion, which eats away at the white areas or increases the dark areas. So that now these numbers are thinner, but you can see that they're still connected, so each digit is a single area rather than made up of multiple segments. So that's one of the uses of morphology. Let's look at another one. Here I have some printed text with a table in it, and maybe I'd like to identify where the tables are or extract information from a table. In this case, it might be useful to find the horizontal and the vertical lines here. Again, we can use morphology for this. If we do a dilation using a very wide but thin kernel, so the kernel is the rectangular area within the image that the morphological operation is operating on, and if we use a very wide but thin kernel, you can see that we get the horizontal lines. It may not be obvious here, but the lines here are actually not as wide as the ones in here. So this dilation operation, not only did it remove all the other text in the vertical lines, but it also shortened these lines a little bit. So to correct for this, we just do the same number of iterations of an erosion on this image, and now these lines should be back to their original length. We'll do the same thing in the vertical direction with a kernel that's tall and very thin. And then again, do an erosion on those lines to put them back to their original length, their original height. And now we can combine these two images with a mathematical operation, an arithmetic operation. we can use the minimum operation. And now you can see we've got the outline of the tables. So this is a couple of examples of how we can use the morphology operation to modify or extract information out of our images. For more computer vision demos, or if you want to try the software yourself, please visit pixelprocessing.com, and feel free to leave comments on this video, and also feel free to contact me. Thanks for watching.